Okay, so we're at 5.2 day 2. It's going to be a longer day 2 because I was going to do example 4 and 5 in day 1, but it just didn't work for the video. So we're looking at general strategies number 3. You're going to use algebraic identity of the difference of two squares to set up applications of the Pythagorean identities. Always be mindful of the target expression and favor manipulations that bring you closer to your goal. So when I'm looking at this next one in problem 4, I'm going to take this side and I'm going to try to make it this side. Okay. So what I'm going to do, and I see right now what I'm going to kind of try to get done. Um, I'm going to take that left side, my cosine t 1 minus sine of t. I'm just going to multiply 1 plus sine of t on the top and bottom, okay, on this left side. So what this is going to do, this is multiplying by a form of 1, okay? But I'm using the idea of the difference of two squares to set up my problem. So now I've got cosine t, 1 plus sine t, over 1 minus sine squared t. And now that 1 minus sine squared t is same as cosine squared t, if you recall from your Pythagorean identities. We've got this switch situation, and I'm going to subtract. So now this is what I'm going to use. So this is the situation. That's my substitution, and I'm going to substitute on the denominator cosine t 1 plus sine t, and I'm going to put in cosine squared t. Now I'm going to see that I can take this cosine t and take out one of these down here. All right, so I'm going to take out those cosine t's, and I'm going to scratch that out. Looks like it's negative. It's not. So I've got 1 plus sine t cosine t, and that's what the right side is equal to. So just notice what I've got done here and how it went, and we'll move on. Now, part of this solving is multiply by a clever form of 1 and working with the conjugates over the conjugate to set up a difference of squares and a Pythagorean substitution. That's what I did there. Expand only the conjugates, leaving the other side of the fraction factored, ready to divide out common factors. Okay, so that's one of the skills that we did. And sometimes when you're looking at these, how do you know what you're doing when you're doing it? And it's just, gosh, just being real comfortable with getting those things done. But we're going to do it again here on this next one. Hey, we haven't used phi, and I will probably end up saying theta. So let's just make these thetas right away, because that's something that I know I'm going to do. As we go through this, I'm still going to, look at this, and the first thing I'm going to do, I'm going to multiply by 1 minus cosecant theta. So I'm going to take 1 minus cosecant theta on the top and 1 minus cosecant theta on the bottom. Now when I get this done, remember according to that last rule, don't multiply it out on top. I'm going to get that going. I've got cotangent squared theta, and I've got 1 minus cosecant squared theta. Now, keep in mind as we're doing this, I'm going to do a little sandbox over here. I've got the cosecant, when we're taking off on this with the Pythagorean identities that we're making work for us here. I would start normally like this, and since it's theta, we're going to do that. And I'm just recalling the relationships here. I want to know what the relationship with cosecant is. So because of that, I'm going to divide by sine squared theta here, and sine squared theta here, and sine squared theta here. And this is cosine over sine, which is cotangent squared theta, plus 1 equals cosecant squared theta. Well, cotangent squared theta is equal to cosecant squared theta minus 1. Notice the order there. I've got to get the order here switched around. So what I'm going to do is I'm going to manipulate the inside of those in this next step. So cotangent squared theta times negative 1. Well, I think I'm going to slow it down a little bit further. Well, no, I guess I can do that. Times negative 1 is going to equal cosecant theta minus 1. Okay. Keep in mind that's what I just did is manipulated this side. A negative 1 is going to come out, and that's going to be like that there. Okay. Now, for the very same reason, I'm going to manipulate the other side because I want to make a substitution. And I've got cosecant squared theta minus 1 down here, but remember, there's a negative 1 involved with that manipulation. Because of that, the negative 1s are gone, and that's going to be positive when I'm finished. And now I can look and manipulate what I'd like because I want to substitute cotangent squared theta in here. Now, I know you're thinking, well, geez, what's he up to here? And I'm going to slow it down a little bit just so you see. I'm going to substitute, and I know it's cotangent squared theta, and I could get rid of those, but think about why I'm here. So I'm going to go back, and I saw some when I was doing the sandbox. I'm going to show you this. If I take this cotangent theta, and I'm just kind of manipulating, working from both sides a little bit just so you can see, you know, I can keep the eye on the prize because what I'm really trying to manipulate is kind of hidden. If I take out a tangent out of this, if I take a tangent out on this side, and I'm taking cotangent theta and I divide out a tangent theta, I get secant theta over tangent theta minus 1. Now, getting this done may not seem like, well, gee, what he's doing, but look at this. I've got my tangent theta, my cotangent theta. I've got tangent theta, but remember tangent theta and cotangent are reciprocals of each other. So, you know, just kind of follow along about what's happening here. And then I've got secant, which is 1 over sine. 1 over cosine. And I've got tangent, which is the reciprocal of tangent. So I've got cosine theta over sine theta minus 1 inside there. Now this is going to become cotangent theta, tangent theta, and these are 1 over sine theta minus 1. And I've got cotangent theta, tangent theta, and that's cosecant theta minus 1. Okay, so if you start noticing what I've got to get to, I've already got the cosecant theta minus 1. I've got a cotangent, and I got another cotangent on the bottom. So this is how I'm going to break this down from this information here. I'm going to use that and set up my stuff at this asterisk. So now I'm thinking I'm going to take and have cotangent theta, cotangent theta, should be cotangent, not cosine. Excuse me, board's kind of funky. So I got cotangent theta and cosecant theta minus 1. Well, over here, keep in mind, I'm going to break down this cotangent theta and this cotangent theta. I'm going to take this one out and let this one become a reciprocal. Okay, so I'm looking at this next step, and if I come up here, these are equals. And I just got to squeeze this stuff over a little bit. So maybe it'll be space for explanation of what I'm doing is a necessity, I guess. I'm just going to slide this stuff over a little bit just to make sure you see where I'm going and what I'm doing. And this is kind of a next line here. So we'll make that. So we're going to go up here to our next thing. Cotangent theta. And maybe I can move that over more. Okay, good. So I've got cotangent theta up top, cosecant theta minus 1 times tangent theta, because that is, maybe I'll slow that down a little bit more so you guys can see that, times 1 over cotangent theta, which is tangent theta. So I've got cotangent, somebody's got to make sure he clearly states what he's saying, cotangent theta cosecant theta minus 1 times tangent theta. Okay, so right now I'm here, and I've got my cotangent theta, tangent theta, times cosecant theta minus 1. Now, at this point, I'm going to take and create this side that I did. I'm just going to get this smaller so you can remember what I was doing. We're going to group this, make it a little smaller so that way I can fit some stuff in there. But this is the reason why I'm doing what I'm doing right now. Now, I've got my cotangent taken care of, okay? Now I've got to get that tangent multiplied out. So I've got cotangent theta and tangent times cosecant, and as we're going here, so my tangent, I'm going to switch that into sine theta, cosine theta. I got cosecant here, so I'm going to multiply by 1 over sine theta, that's my cosecant, minus tangent theta. Okay, so that's a minus. And now I'm at cotangent theta, and I'm at 1 over cosine theta, which is my secant theta, minus tangent theta. Okay, and then I've got my final step, cotangent theta, secant theta minus tangent theta. Okay. Now I hope you understand that the side stuff over here was to help you follow along what I was about to do. If you could have seen it without that explanation, great. If you couldn't, that's fine too. But this was just identity. This was identity work. That's for recall. And over here was this working backwards. Okay, to get that next step done. Okay, and that's what I wanted to example, so I gave you an example on it as we went through. Now, disproving non-identities. Okay, so obviously not every equation involving trigonometric expressions is an identity. How can we spot a non-identity before embarking on a futile attempt at a proof? Try the following exploration. Now, prove or disprove that this is an identity. Cosine 2x is equal to 2 cosine x. Now, graph y equals cosine 2x and y equals cosine x on the same window, or in the same window. Interpret the graphs to make a conclusion about whether or not the equation is an identity. Now, I've got those two graphs here in my window. And the blue one is the cosine 2x, so this is my cosine 2x. Okay, and the red one is my 2 cosine x. Okay, as I'm going around. Now, hopefully you can tell as we look at these graphs, the graphs lead us to conclude that these are not equal, and therefore they're not an identity because they're not the same graph. Okay, and even if it were in the window the same graph, I'd still have to go about proving it, because the proof of the window itself isn't the fact that it's an identity, because we only have a very limited picture of how the graphs behave in a certain window. So that's why we do the identities, to prove that they work like that all the time. Okay, so let's go on to our next question. With the help of the graph, find a value of x for which cosine 2x is not equal to cosine x. Well, I've got several. If you look at the graphs themselves, prove when they're not equal. I mean, anytime they're not on top of each other, they're not equal. Okay, so as I'm going through, cosine 2 theta, or 2 times 0, not theta, 2 times 0 is 1, okay, as I go through. And if I go 2x, it's 2. So I already know that 1 is not equal to 2, so I've got that done. And in 3, does the existence of the x value in part 2 prove that the equation is not an identity? Okay, yes, proof by a counterexample. So I got a proof by contradiction. I showed that they weren't the same graph in one situation inside my window. Okay, that proof by contradiction, all I have to do is prove one situation where they're not equal. Okay, now in 4, graph y equals cosine 2x and y equals cosine squared x minus sine squared x in the same window. So I've got those down. So I've got cosine 2x and cosine x squared. Please notice how I've got to write cosine squared x as cosine x quantity squared minus sine x quantity squared in my graphing calculator. This is the only way I can do it in my graphing calculator. Now, to make conclusions about whether or not that these two graphs are equal as an identity. Well, I graphed these two together and I caught a picture, okay, because this first one, the cosine 2x was blue, and it was blue all the way across my window. And I took a picture of my graphing calculator as it was overwriting this other graph in the window. And it changed the blue lines to red, which kind of tells me that the graph is going over the same area, okay? So now this graph leads us to conclude that this could be an identity relationship. But again, why I'm saying it could be an identity relationship is the fact that I don't know what the behavior is outside of the window. So that's why I would go about proving that they're an identity relationship by manipulating one side of the equation to become the other side of the equation. So, do the graphs in part 4 prove that cosine 2x and cosine squared x minus sine squared x is an identity? Well, no, and for the same reason, since the graph window cannot show the whole graph, the two graphs could differ outside of the viewing window. So, how do we go about doing it? We write an identity to see how we go from cosine 2x to cosine squared x minus sine squared x. Now, the identities in calculus. These are identity values that you'll actually see in calculus as we get going. Okay, so pay attention to them as we're doing this, because you'll actually have an opportunity to recall these in calculus as well. Cosine cubed x, okay, is found by 1 minus sine squared x. Well, think about it. I'm just factoring out cosine squared x, and that's what I can do here. So that kind of makes sense. Secant to the 4th x, well, secant squared x is 1 plus tangent squared x. So if I'm just substituting and breaking it down, so that seems to work as well. Sine squared x, well, this is 1/2 minus 1/2 cosine 2x. So this is an identity that we haven't seen yet, okay? Cosine squared x is 1/2 plus 1/2 cosine 2x. Notice the difference between sine squared x versus 1/2 minus 1/2 cosine 2x. And cosine 2x is the same, but it's a plus sign in between. Sine to the 5th x. Now, sine to the 5th. We take out a sine, and we're saying that sine to the 4th x is 1 minus 2 cosine squared x plus cosine to the 4th x. And now sine squared x and cosine to the 5th x is cosine to the 4th x, they've got in sine squared, so they're kind of splitting this down to become this relationship here. So when I start making these identities, I still have other relationships that have been proved, and they're considered identities to help us switch things over for our future. Ooh, somebody has done this identity, so let's talk about this a different way, and I'll show you how we came about this. Okay, so let's get this going. I'm going to prove how this, in number 6, how this was arrived at from here. Okay, so I'm going to start over here. I'm going to start on the right side here. I'm going to factor out a sine squared x. Okay, so I'm going to factor out sine squared x, and I've got 1 minus 2 sine squared x plus sine to the 4th x times cosine x. So I factored out sine squared x. Well, here, that's a perfect square of 1 minus sine squared x, so I'm going to factor that out. So I'm going to factor things down. 1 minus sine squared x times 1 minus sine squared x times cosine x. Okay, now keep in mind 1 minus sine squared x's are cosine squared x's. So I'm going to back up for a second and just talk to you about this and put this parenthesis back in. Because this is cosine squared x here, this is cosine squared x here, so that's where I'm going to get 2, 4, and 5 cosine to the 5th x. So that's my next step, sine squared x, and I'm substituting cosine squared x for 1 minus sine squared x, and cosine squared x in again, and cosine x. Well, the end of this is quite nice and quick. I've got cosine squared x, and then I've got my cosine to the 5th x to follow that up. So we're done. Okay. Now on this next one, sine to the 5th. Okay, we're going to get rid of this one too. Sorry, I thought I had erased those earlier. But when we're doing this, I'm going to start on the more complicated side. And just like I did on the previous problem, I'm noticing that this particular value is a perfect square. Okay, and that perfect square is 1 minus, so if, and for you to see what I'm doing, if it were this, it'd be equal to 1 minus x squared. Well, what's my x? It's cosine squared x. So now, keep that in mind. That's the pattern I'm using, okay, as we're going through. So now I've got 1 minus cosine squared x times 1 minus cosine squared x. Hey, that's the same thing, times sine x. Now, what am I proving? Keep in mind, sine to the 5th. Well, this is the same, and just to make sure that you see it, sine squared x plus cosine squared x equal 1. And remember, I flip-flop the sine and the cosine around because, you know, commutative property of addition. But I'm going to get it so that sine squared x is equal to 1 minus cosine squared x, and that's what I'm substituting in. So I'm going to substitute in sine squared x times sine squared x times sine x. Well, 2, 4, 5, and I've got sine to the 5th x, and we are done with that particular problem. On the next page, or actually, there is a problem that I want to emphasize on number 37. So we're going to bring in a new page here, and we will get rid of this old page, and we'll bring in a new page. And we're going to do problem 37 from your textbook. This is on 5.2, day 2, okay, number 37. We have sine x minus cosine x all over sine x plus cosine x equal 2 sine squared x minus 1 over 1 minus 2 sine x cosine x. 2 sine x cosine x. Yep, 2 sine x cosine x. Just making sure I wrote that down right. Okay, so here's the deal. I see the value of 1 here and here, okay? So that value of 1 is the same as sine squared x plus cosine squared x, or cosine squared plus sine squared x. So I'm going to substitute. So this next step, I'm going to show the things I substitute in a different color. So I've got minus cosine squared x, and that should be like that, plus sine squared x, all over Got another substitution here. Cosine squared x plus sine squared x plus 2 sine x cosine x. Okay, so now if I like reorder a little bit on a few things, this next step, I'll just go to black because I'm going to combine them again. So now I'm looking at the idea that I've got distributing my negative, and I got 2 sine squared x minus cosine squared x minus sine squared x. Okay, so I've got sine squared x minus cosine squared x on top eventually here when I combine like terms. And on the bottom, I'm looking at, I'm going to get that sine squared out x up front. And I'm going to get that plus 2 sine x cosine x. And then I'm going to do cosine squared x at the end. Okay, so I just reorganized the top and the bottom. So now my change is this sine squared x and this sine squared x are going to combine to be just sine squared x. So I've got sine squared x on top minus cosine squared x. And then on the bottom, if I'm noticing this change here, I've got sine x plus cosine x squared. And if I notice this idea, I've got the difference of two squares on top at two perfect squares on each side. If I factor out and expand, with my factors here, I'm not going to expand by multiplying, I'm going to expand by factoring things. I've got sine x minus cosine x and sine x plus cosine x on the top, and on the bottom I got sine x plus cosine x and sine x plus cosine x, just to show that those are going to be 1. Okay, and my final answer on this has been achieved because I was supposed to prove or show that sine x minus cosine x over sine x plus cosine x was the same as what I started with, and that's what I've got up here right there. So I'm done. Okay, and that was problem 37. Now, keep in mind as we're going through this was our assignments for 5-2 day 1, 5-2 day 2. Okay, so you know what's going on. Be very familiar with the trig sheet that was in your notes today, along with the green sheet that was handed out the first day. You will get a clean copy of that sheet for a test, but the things that are expected for you to be memorized are covered up, and the ones that I have, the double angle identities, the power reducing identities, and the half angle identities, those are the ones that I'm going to allow on the test without with a card. So these you don't have to memorize, but the other ones you will, all the other ones. So keep in mind as we're going, those are the expectations to prepare. I hope things are going well. I hope you're getting these videos understood and that they're helping you. And you keep getting your stuff done online and asking questions. And I hope you guys have a great day.